Hello my dear students, this is P. Venkateshwarlu, PGT Physics. In previous video, we are completed 9th chapter, Mechanical Properties of Solids. In this video, we have to start 10th chapter, Mechanical Properties of Fluids. 10th chapter, chapter 10, mechanical properties of fluids. Okay, so what my children? Mechanical properties of fluids. Okay, see here. Whenever we are applying force towards this type of fluids, we can observe some changes. Okay, understand? So we are discussing about different types of properties by the application of force in this chapter. We can start with what is fluid. Okay, so fluid. So first of all, what is fluid, my children? What is fluid? Yes, the substance which can flow. The substance which can flow. To flow. The substance which can flow is called fluids. Okay. Example: air, gas, water. Okay. Understand? Here, fluids are divided into, classified into two types. What are they? Liquids, gases. Okay. The substance which can flow is called liquid. Examples: liquids or gases. Fluids, the substance which can flow. These are two types: liquids and gases. Liquids and gases. Understand, my children? Okay. Next, fluid statics. Fluid statics. Next one, fluid statics. So fluid static means statics means rest. The study of the fluid which is at rest. The study of the fluids at rest is called fluid statics. Okay, static means rest. Understand, my children? Next, fluid statics means rest. And hydrostatics, this is also called hydrostatics. Okay. Next one, fluid dynamics. Fluid dynamics. Fluid dynamics are hydrodynamics. Fluid dynamics, which is defined as the study of the fluid which is in motion. The study of the fluid which is in motion is called fluid dynamics or hydrodynamics. Hydrodynamics. Okay, so this is the introduction, my children. So what is fluid? Types of fluids, hydrostatics and hydrodynamics. Okay, so the study of the fluid which are in motion or which are in the study of the fluid which is in motion or which is at rest is called hydrodynamics. Hydrodynamics. Understand, my children? Next, we are discussing about thrust. Thrust. Next important one, thrust. Okay, thrust, which is defined as a normal change in momentum. normal change in momentum per unit time is called thrust. Normal change in momentum per unit time is called thrust. Indirectly, we can say a force is applying normally to the surface, or a force acting normally to the surface is called thrust. Okay, understand? See here, thrust indirectly we can say F, perpendicular force we can say thrust, which is equal to dP by dt. Okay, means normal change in momentum. Normal change in momentum per unit time is called thrust. Okay, so what is the SI unit of thrust? Yes, according to force, SI unit of force is Newton or kilogram meter second power minus 2. Okay, so indirectly thrust is a force. That's why it is vector quantity. We can represent with direction and magnitude. With the direction and magnitude. Understand, my children? Thrust. Thrust means what? Normal change in momentum per unit time is called thrust. Indirectly, normal force. Normal force in a fluid is called thrust. Okay, my children? Yes. Next, coming to pressure. 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 The pressure, in generally we are defining pressure is force acting per unit area. In the fluid dynamics, we can discuss about thrust acting per unit area. Pressure is defined as thrust. Thrust acting per unit area is called pressure. Means F perpendicular to unit area. Pressure is equal to normal force per unit area, thrust per unit area. SI units, my children. SI units are Newton per meter square or pascals. Dimension formula m power 1, L power minus 1, T power minus 2. Okay, understand? So this pressure we can define P is equal to limit delta A tends to 0 dF by dA, delta F by delta A. It is another formula. Okay, differential formula. Okay, my children. So this is about pressure. Pressure is equal to thrust per unit area. P is equal to perpendicular force per unit area. So now, another unit is Pascal. We know that 1 Pascal is equal to 10 power 10 dynes per centimeter square. 1 Pascal is equal to 10 dyne per centimeter square. Okay. So another unit is atmospheric pressure. Atmospheric pressure 1 atm is equal to 1.013, my children. So 1.013 into 10 power 5 pascals. 1.013 into 10 power 5 pascals. Okay, understand, my children? So dimension formula m power 1, L power minus T power minus 2. 1 Pascal. Pascal is equal to 10 dyne per centimeter square. 1 atmospheric pressure is equal to 1.013 into 10 power 5 pascals. So this is about pressure, my children. This is about pressure. So next, applications of pressure. Applications of pressure. Applications of pressure. Applications of pressure. Okay, here so many applications are there for pressure. Okay, see here. So first, sharp surface and blunt surface. Okay, so how we can cut vegetables or anything? By using knife. Knife having small area, sharp area, small area, sharp area. So it will not cut blunt surface. Blunt surface cannot cut two parts of a single object. Okay, so next one, camel. Camel easily walk on the sand, but human being cannot walk. Okay, railway tracks are laid in large sized wooden or iron sleepers. Okay, iron sleepers. So the area increases means pressure decreases. Okay, so next, sharp needle pierces the skin, but dull needle can't. Okay, because of applied force is same. Applied force is same. See here, many applications is there. Okay, so while cutting and bending, many purpose we are using the pressure. Okay, so while cutting cloth, okay, while cutting so iron materials, everything. Okay, so we are applying force indirectly, force, and we call it pressure. Okay, so we know that pressure P is equal to force per unit area. Okay, so if area increases, pressure decreases. Pressure decreases. If we can reduce the area, pressure decreases. Pressure decreases, my children. Okay, so next, density and relative density. Next, we need to discuss about density and relative density. Density is defined as mass per unit volume. Okay, mass per unit volume. Density rho is equal to mass per volume. Mass, it is denoted M. Volume, it is denoted V. See, its SI units kilogram per meter cubed. Kilogram per meter cubed. So then we can write SI units kilogram meter power minus 3. Meter power minus 3. It is scalar quantity. It is a scalar quantity. Scalar quantity means it having only magnitude, not direction. See, it's a dimension formula. M power 1, L power minus 3, T power 0, T power 0. Understand? See here, the conversion of density, it's yes, 1 kilogram per meter cubed is equal to dimension formula for density is M power 1, L power 3, T power 0. Okay, so this is about density. Density of water. Density of water is 1000 kilogram per meter cube, or we can say 1 gram per cc. 1 gram per cc. 1 gram per cubic centimeter. Understand? Density of water, that is. Next, relative density. Relative density matters. So next we need to discuss about relative density. Relative density. Relative density or specific gravity. specific gravity. Okay, so relative density, which is defined as the ratio of density of the material to the density of the substance. So what is the relative density, my children? Relative density, which is defined as the ratio of density of the substance to the density of water at 4 degrees centigrade. Yes. So relative density rho is equal to density of substance to the density of water at 4 degrees centigrade. So why we can take 4 degrees centigrade means water at 4 degrees centigrade which occupies maximum volume. Understand? See here, it is a ratio. Means it having no SI units because numerator denominator gets cancelled. No SI units. At the same time, it having no dimension formula. It having no dimension formula. So what is relative density and specific gravity? Relative density or specific gravity, which is defined as density of the substance to the density of water. Okay, so it is the ratio, it having no SI units and no dimension formula. Okay, my children. So this is about relative density. So understand, my children, this fluid. Fluid means what, my children? Fluid, the substance which can flow, is called fluid. So examples of fluids, liquids, gases. Okay, see these liquids and gases having no particular shape and volume. Okay, so the shape of the this fluids is the shape of the container. So we know that fluid statics means rest. Okay, the study of the fluid at rest is called fluid statics. Fluid dynamics means which is in motion. The study of the fluid which is in motion is called fluid dynamics. Next, thrust. Normal change in momentum per unit time is called thrust. So SI unit of thrust is Newton. Next, pressure. Pressure means force, normal force or thrust per unit area. In general, force acting per unit area. See, in this case, we have to take thrust acting per unit area for normal force per unit area. SI units Newton per meter square. It is called Pascal. 1 Pascal is equal to 10 Newton per centimeter square, and 1 atmospheric pressure is equal to 1.013 into 10 power 5 pascals. Okay, so we know that some practical applications of this pressure. Okay, small area. For small area, so applied force is converted into large pressure. Okay. So here small needle can pierce our skin but not blend surface even though we are applying same force. So and the next one, density. So what is density? Density, it is defined as mass per unit volume. Okay, relative density, yes. Density of the substance to the density of water is called what, my children? Relative density. Relative density, it is a ratio which having no SI units, no dimension formula. Okay, my children, tomorrow we'll start the next one. Thank you, my children.